Hi there. So in this video, we're going to take a look at module 65 about oligopoly. There is 64 and 66 that also get into the weeds of it. This one goes into some detail about game theory. So the first question in the Check Your Understanding says, suppose world leaders Nikita and Margaret, these are supposed to be Nikita Khrushchev and Margaret Thatcher, who are not actually alive at the same time and leading their respective countries, but whatever. They're engaged in an arms race and face the decision of whether to build a missile. Answer the questions using the payoff matrix, which shows how set of each actions will basically affect each other. And it tells us the numbers are utils, gained, or lost. And the book has a weird way of kind of designing these template or these payoff matrices, but basically it's saying the number on the left still goes with the player on the left. So the negative 10 goes with Margaret, the negative 20 goes with Margaret, the negative 10 here goes with Nikita, and this 8 goes with Nikita. So we're going to first solve it. If we're Margaret and we think Nikita is going to build the missiles, then we should build the missiles as well. And if we're Margaret and you think Nikita's not going to build, then we should also build the missiles because 8's bigger than 0. So negative 10's bigger than negative 20, and 8's bigger than 0. So we would say that Margaret's always going to build the missiles. We know that if Nikita knows that, then Nikita can either build the missiles and get negative 10 or don't build them and get negative 20. So they're going to build them as well. If Nikita thinks Margaret's going to play irrationally, then Nikita could build the missiles and get 8, get an advantage, or get 0 by not building the missiles. So obviously, kind of the best outcome here in terms of our thinking would be the one where neither one builds the missiles, right? You can sum them together. That would be actually the optimal outcome. This one's negative 12, negative 12, negative 20, but they're still going to end up in this box, the Nash equilibrium, with build, build. Which set of actions maximizes the total payoff? Well, that's don't and don't, right? So we added these two together. Why is it unlikely they'll end up there? Because they're non-cooperative and their dominant strategies yield them the Nash of build, build. Like realistically, they have two dominant strategies. They're both to build the missiles and they're both going to end up in the Nash. For each of the following characteristics of an industry, explain whether the characteristic makes it more likely or less likely for them to play non-cooperatively. So we're basically saying, would they cooperate or not? And if there's an oligopolist that expects a bunch of new firms pretty soon, then they're not going to cooperate, because they are uncertain of their payoffs, right? If you don't really know like what's going to be the situation soon, then you're not going to cooperate. It's very difficult for a firm to detect whether somebody else has raised output. Well, that's also going to make you non-cooperate because you can't like tell if they're cheating. And so you're better off just doing it basically on your own. The firms have existed for a really long time while maintaining high prices. Well, this would be collude because it's benefiting us and it's a stable outcome, benefiting and stable. So it's really just kind of thinking through these possibilities. The last part says, refer to the payoff matrix. You and your competitor must decide whether or not to market a new product. And so you give you in the top and your competitor on the left. If you market the product and your competitor does not, how much profit will you earn? So if I market and my competitor does not, I will make 400. Just read the payoff matrix. If you market the product, what should your competitor do? Well, if I'm going to market the product, then my competitor could either earn 100 from marketing or 0 from not, so they're going to market. Do you have a dominant strategy? Well, let's see. If my competitor decides to market the product, then I should market the product and get 100. 100 is bigger than 0. If my competitor doesn't market it, I should definitely do that. So yes, and that's to market the product. Because, and we're going to compare the values here, 100 is bigger than 0. So I'm comparing this value, and 400 is bigger than 0 for that side. So you need both because otherwise you can't really say, yes, I have a dominant strategy. Is there a Nash equilibrium? Well, to do that, we have to solve for the other side. So if my competitor knows I'm going to market, then they can look at it and say, should I get 100 or 100 or 0? They're going to prefer 100. And the competitor has the same outcome as we do, but it means that we have two circles in a box. So yes, and it's market, market. Let's take a look at the multiple choice. For question number 1, each player has an incentive to choose an action that when both players choose it makes them both worse off. This describes a prisoner's dilemma, which we actually taught in class. Which of the following types of oligopoly behavior is or are illegal? Tacit collusion's not. Cartel is. Tit for tat is not. So the only one that is the option 2, B. That's the only one that's illegal. 3, a situation in which a player in a game chooses the action that maximizes their payoff given the actions of the others, but ignores the effects on the other people. In other words, you're just doing what you want to do, and the outcome basically depends on both players being selfish and doing what they want to do. They're playing non-cooperatively. So we would call that a Nash equilibrium. Now, a lot of students want to say that this is a dominant strategy, but it's not. A dominant strategy is not choosing an action that maximizes your payoff, just ignoring the effects of the others. The dominant strategy means you're always choosing the same action. Those are two different things. This is a Nash equilibrium that's different from a dominant strategy. Number 4, with this particular payoff matrix, it says, suppose that Louise discovers Thelma's action before choosing her own. Based on the matrix, Louise will. Now, I can tell you that if it's a standard payoff matrix with a prisoner's dilemma, it doesn't matter really whether they know what the other one's going to do, because they both have dominant strategies to confess. So let's go ahead and solve that and see. If Thelma thinks that Louise is not going to confess, Thelma can get 5 years or 2 years. Thelma will prefer 2 years, so Thelma will confess. If Thelma thinks Louise is going to confess, Thelma could get 20 years by not, or Thelma could get 15 by confessing, so she's still going to confess. If Louise knows that Thelma's going to confess, then Louise can say, well, I could basically get 20 years or 15. I'm going to prefer 15. And if Louise thinks Thelma might not, then Louise can get 5 or could get 2. So Louise is still going to always confess. They both have dominant strategies to confess. And so we would say A, regardless of whether or not Thelma did. Which of the following is true on the basis of the payoff matrix? Louise has no dominant strategy? No. Thelma has no dominant strategy? No. Both of them have dominant strategies to confess. C. So hopefully this helped you with Module 65. I'll see you next time.